All right, math fans, our topic for today is completing the square. This is going to be a method that we can use to solve quadratic equations if factoring doesn't work. Now, before we begin, let me give you your joke of the day. How do rabbits travel? And the answer is by hairplanes. Okay, so before we actually get into solving quadratics by completing the square, we're going to actually backtrack a little bit. So we're going to start with a problem if we have x plus 3 and we want to square a binomial. So when we square a binomial and we work that out, that's x plus 3 times x plus 3. Now, whether you call it FOIL or I like to say double distribute, I'm going to distribute this x. So x times x, we get x squared. And then we get x times 3 is 3x. And then we distribute again. That's 3x. And then 3 times 3 is 9. And what happens is we collect the like terms, but what you will always notice when you square a binomial, the middle term is going to be the same. So basically what happens is we end up getting 2 of these. So overall, we would say this is x squared plus 6x plus 9. Now notice that the number 9 is a perfect square. It's 3 times 3, okay, from here. Notice that x squared, the first term, is a perfect square. That's x times x. But the middle term, we get that from taking the 3x and basically doubling it, multiplying it by 2. All right, let's do another one. Let's do x minus 4 squared. Okay, now I'm going to start skipping some steps here. We square the first term, there's x squared. And then the last term is negative 4 squared, that's positive 16. But the middle term is we're going to have negative 4x twice. So that's minus 8x. Every time we square a binomial, what we get is called a perfect square trinomial. And you can always write it out like this, you can always work it out, but what I want you to understand is that this middle term will always be the same. We have 2 of those, all right? Negative 4x would be the middle term, we have 2 of those. So what happens, let's say we use this concept here. Let's try one more. We'll do x plus 8 squared, and I'll actually square this out, or I'll write it out, and we get x squared plus 8x, and then plus 8x again, and plus 64. So we get 2 of these. That's 16x plus 64. Okay, so there's our perfect square trinomial. Now what happens though if we're working backwards? Let's say we have x squared plus 10x plus something, and we want to make that a perfect square trinomial so that we would then be able to factor it. Well, knowing that the middle term here, for this to be a perfect square trinomial, we know the middle term has to repeat itself. So in other words, 3x and 3x, 8x and 8x. Here this was negative 4x, negative 4x. So we know that 2 times something is going to give us this value. Well, you can think about that. The number would be 5, right? 2 times 5 would get us 10x here. And then the number 5 squared would get us positive 25. So this would be x plus 5 squared. So what we're doing here, if I have these 2 terms, I'm trying to complete my perfect square trinomial. I'm trying to figure out what number can I add as a constant that I can then factor this as a binomial squared. Okay, so again, how do I get the middle term? Well, it's 2 times something. So what I'm going to do is divide by 2, and that gives me 5. Now that number 5 is what I'm going to have here in my factor, my binomial. And going back here, if it was plus 3 squared, the last term would be 3 times 3, which is 9. Negative 4 squared, the last term would be positive 16. 8 times 8, the last term is 64. So 5 times 5 is 25. And then we can factor it. This is called completing the square. Okay, so let's do a little bit of practice here. Find the value that completes the square and then rewrite as a perfect square, and I will say perfect square trinomial, and then we'll factor it. Okay? So x squared minus 30x plus something. Now, we know that these, the two values that make this, are the same. So if I divide by 2, negative 30 divided by 2 is negative 15. Now the last term, though, is that number squared. So negative 15 squared is positive 225. There's the perfect square trinomial. Now we can factor it, and it would be x minus 15 squared. So this would be our perfect square. X minus 15, that quantity squared. So all we're doing is we're working backwards here. Instead of squaring the binomial, we're asking ourselves, if we can get a perfect square trinomial, what would the factors be for that? So here, 24a, remember we had 2 of those that would add up to this. Divide by 2, so half of 24 is 12. 12 times 12, or 12 squared, is 144. So this factors to a plus 12 squared. Divide by 2, we get m squared. This would be negative 18 squared would be 324. Negative 18, negative times a negative is a positive, and that would be m minus 18, that quantity squared. So we're just reversing the process here. And again, if this gets confusing what I'm doing, instead of doubling the middle term, I'm starting from the middle term and I'm taking half of it. I'm dividing by 2 with the understanding that my last term must be a perfect square. It's this number squared. So I'm finding this number, negative 15 or 12 or negative 18, and then squaring that gives me these values so that I can factor it. Okay, now we can keep going here. It does get a little bit tricky. What if we have an odd number, say like negative 15? Well, half of that we divide by 2. I'm going to keep this as a fraction. Now, I would square this. So when I square a fraction, I'm squaring the top number and the bottom number, and this would be positive 225 over 4. That's the number that I'm adding here. And then my factors would be x minus 15 over 2, and that's squared. Even if I have a fraction here, if I divide that by 2, that's 1 over 18. When I square that, that's 1 over 324. 18 squared is 324. And we get r plus 1/18 squared. And just to show you, if you doubt that, we can always work it out. We would get r squared. Now this would be 1/18 times r, and then we distribute here. That's also 1/18 times r plus 1 over 324. These are like terms. Now if we add that, that's 2/18, which is 1/9 r. So r squared plus 1/9 r plus 1 over 324. So this is a perfect square trinomial. And this is called completing the square. All right, now, so where the process is going to come into play is when we are trying to solve quadratics. Now, before we actually do this, we're going to talk about one more type of equation, one more way that we can solve here. Let's say we have x squared equals 25, okay? So we have some value squared is equal to 25. To undo a square, to solve this, we take the square root of both sides. Now you would say probably x is equal to 5. And that would be correct, right? 5 times 5 is equal to 25. That makes this equation work. Where we have to be careful, though, is that if we square a negative number, we also get a positive. So we would say that x is plus or minus. So we write plus on top of minus here. That means plus or minus 5. We have two answers. We have negative 5 and we have positive 5. Let's say we have x squared is equal to, we'll say 49. All right, to solve this, we take the square root of both sides. When we solve a quadratic by taking the square root, we just have to remember we have two possible answers. Positive 7, but also negative 7. If we square a negative, we get the 49. What if it was x minus 2 squared equals 36? This is still a perfect square on this side. I can undo a square by taking the square root. Now when I take the square root of x minus 2 squared, what we get is x minus 2. But remember, we have two possible values, positive or negative 6. So now we're not done, because if we're solving for x, we need to move negative 2 to the other side. So we add 2. And what we get is x equals, that's just 0. Now this is 2 plus or minus 6, which means we have two solutions here. Either 2 minus 6 or 2 plus 6, which is negative 4 and positive 8. So we've got two answers to this equation here. If I take negative 4 and subtract 2, I get negative 6. If I square that, I get positive 36. If I take 8 minus 2, I get 6. Square that, I get positive 36. Both of these are solutions. Okay, that is the end of part 1.